I'm going to draw my angle bisectors of my isosceles triangle ABC. The third one, coming from the vertex angle, is also going to be the median of triangle ABC. The three bisectors are all going to meet at this point I. I'm going to call this angle X. The distance from B to I is 8. And I'm going to call this distance from B to M, we'll call it P. And the congruent sides will have length Q. Using right triangle ABM, we have that the cosine of angle ABM is adjacent over hypotenuse, or P over Q. From right triangle IBM, we have that the cosine of angle IBM is P over 8. In terms of x, this is cosine of 2x and cosine of x. So we can use our angle sum formula and substitute. We'll simplify and solve for q, and we get 32p over p squared minus 32. The side lengths of triangle ABC are integers, including BC, which means that 2 times p is an integer. Let's let r be equal to 2 times p, and we'll solve for p and p squared in terms of r, and substitute it into our expression for q. This gives us 16r in the numerator and r squared over 4 minus 32 in the denominator, and we'll simplify this to 64r over r squared minus 128. Q is a side length of our triangle, so it must be positive. This means our denominator must be positive. 128 is between these consecutive squares, which means that r is greater than or equal to 12. If we take another look at triangle BMI, because BM is a leg of this right triangle, it's shorter than the hypotenuse, which has length 8. This means P is less than 8, and substituting for R, this means R is strictly less than 16. This means our bounds on R are 12 and 15 inclusive. So we can try these values of R and see which gives us an integer value of Q. We'll start with the smallest value of R, which is 12. Solving for Q with this equation, we get an integer. Since we're asked to minimize the perimeter, we could stop here, or we can check the remaining values of R. And in fact, when we do so, we don't get any other integer perimeters. So we can use R equals 12 and Q equals 48. Our perimeter is 2P plus 2Q, or R plus 2Q, and our answer is 108. If you'd like me to solve any other contest problems, please leave them in the comments.